Thank you for that introduction, and thank you, Divya and Mirella, for a really interesting talk. I'm Navneet. I'm a senior engineering manager at Thumbtack, and today I'll be talking a little bit about shaping experimentation culture, especially on machine learning teams, where you have problems around data science, applied science, machine learning. And a lot of, I saw that a lot of sessions here today are talking about very specific problems. At Thumbtack, we have a lot of different problems around machine learning and data science. But before we jump into sort of the details of my talk, there's one thing I want to share here. There's this really interesting quote by Adam Grant, and it talks about there being a failure to understand that a lot of different problems you can sort of face and think about from a very data science standpoint. Like, for example, if you're just recognizing that every opinion that you hold and at work is just sort of a hypothesis that you're waiting to explore, it's a very interesting way to think about your problem space and how you want to approach it. So a little about Thumbtack. For those who may not know, Thumbtack is one of the largest marketplaces for home services in the US. It's available everywhere across every county in the US. And it's a great way for you to be able to help care for your home, one of basically most people's largest assets. And we help sort of connect you with local businesses all across the US. So with regard to my team at Thumbtack, we're a cross-functional team of engineers, back-end machine learning. We have data scientists, applied scientists on my team. And we work on a lot of interesting problems across search experience. We work on problems around search ranking, auction dynamics. We also work on problems around demand supply challenges. So basically, how do you better utilize supply or supply of professionals on our platform? And on my team for the last few years now, we've been running a lot of experiments, 25 to 30 experiments on average in a year. And this is, again, of course, encompassing both machine learning problem spaces as well as data science optimization problems. And there's a lot we've learned over the years. And I think I want to sort of highlight a few key learnings from my time leading machine learning teams at Thumbtack for the last couple of years. Of course, a lot of these learnings weren't very obvious a couple of years back, but as I was thinking and retrospecting on, what are things that we did in order to, build sort of a successful machine learning team, there were a few key takeaways that came to my mind. So there's just 4 of them that I'll be talking about today. The first one is centered around maximizing learnings. The second one is centered around, not shying away from larger investments. The third one is sort of centered around building an alignment. And then the last one is sort of centered around experiment velocity. If you don't, take away anything else from my talk, try and have a look at the slide, read through it, and hopefully by the end of the session, a few of these learnings are things that you identify with, and hopefully those are things that you'll think about when you're approaching experimentation culture on your respective teams. So in terms of an introduction, so we already saw, let's say, Mirella, and that we are talking about one of the problem spaces. If you think about any kind of experimentation, you're generally thinking about, let's say, you have some hypothesis, you'll come up with some kind of offline model that you might build, look at metrics like F1, precision, etc. We're all used to all of these kinds of metrics for measuring offline success. And especially at a company like Thumbtack, which has, it's a more B2C model, so you can actually, run A/B tests against the millions of consumers that exists on our platform and who are actively sort of using our platform. And so, of course, at the end of this, experiments fail or succeed, and you learn from it, and you continue iterating on sort of different kinds of optimization spaces, right? But one of the things that I have learned the hard way definitely is testing frameworks alone are just not enough. I mean, one, there's uncertainty of experimentation. So a lot of experiments that we run tend to fail. We all know this. The second thing, that is, like, people talk about experimentation on different teams, different companies, and a lot of it is influenced by the inherent experimentation tooling or the culture within a lot of companies. So we shouldn't take that aspect, of course, for granted. And then the third is, of course, one of the problems a lot of people I talk to tell me about very often is there's a very greedy approach to experimentation. You're always thinking about, okay, this seems like a very interesting way to solve this particular problem. Let's just go after it. Let's just put some resourcing, allocate time and money. Let's just go after this very interesting problem. But on the downside, like the minute it fails, a lot of people are very also quick to sort of judge whether or not it succeeded, and they're like, okay, it didn't work, let's try something else. While initially you thought, okay, this is a great idea and a great approach to, let's say, solving a particular problem. So the first one, again, let me dive a little more into sort of experimentation uncertainty for those who may not be as familiar with some of the A/B testing sort of methodologies that might come into play. So for example, at a company like Thumbtack, you'll notice like this is one of the problem spaces my team deals with. It's how do you rank professionals within our marketplace such that you show the most relevant professionals for our customers and help them like find the best professionals for their job. So you might decide, let's optimize how you rank this list of professionals, and teams might have very user-centric goals. Like of course, your problem might have machine learning-centric metrics like F1, precision, etc. But for the business, you have metrics like conversion, engagement, and all of these things that lead to business outcomes. Now, of course, based on the user problems, you might test different hypotheses. And at the end of the day, a lot of experiments fail, right? That's just the nature of experimentation, especially A/B testing. Now, the first, therefore, takeaway that I want to talk about here is you really want to like start thinking about your problem space in terms of maximizing learnings. What does that mean? It means let's sequence our experiments in such a way that you learn something about the key dimensions of your problem space. So for example, have a look at the left side of this diagram. You'll see that, let's say if you have a problem like ranking, right, that I showed you in the previous slide, you can easily think of, hey, here are different features I can test out. There are a bunch of different machine learning models and algorithms I can try out. You might even decide, let's change the optimization target entirely, whether it's one class, multi-class, multi-objective optimization, however you, let's say, choose to frame that problem. So you might think, okay, here are a few different dimensions, but then most people, when you think about experimentation, you go after a particular approach, and most teams tend to just sort of go after the most interesting problems and approaches that they feel might deliver value for them. That's almost like hitting darts on a dartboard. If you think about your conceptual experimentation or hypothesis space, that's almost like you're hitting darts on a dartboard. It sometimes works, sometimes it doesn't. You start building intuitions around these problem spaces, but I don't consider it such a great way to think about the problem space. The other way, let's say if you are having a problem around the search experience, right? Let's say you have a hypothesis that the visual cues that you see on a page are something that influence customer behavior, conversion, or whatever outcomes that you're interested in. Now, the search experience flow that you're trying to optimize, there might be so many different dimensions to that problem, right? But visual cues are just one key element that you have a hypothesis around. So the way you want to think about then sort of these problem spaces is start trying to not just sequence your experiments based on whatever is the greatest value that you sort of foresee. Start trying to identify key problem spaces. And this becomes really crucial when your team is asked to, let's say, take on a new problem space. Most people think of features and algorithms and optimization targets, but think about key dimensions, and sometimes these key dimensions could be specific, feature spaces. They could be, things that are very relevant to your product surface. Sometimes it could be things like visual cues, where changing different visual cues is almost like a dimension of your problem. But when you think about a model, you don't necessarily map that to visual cues here. Like, for example, at Thumbtack, one of the things that came into play is as we started identifying these kinds of visual cues or key dimensions of our problem space, we realized that we can really influence outcomes much more strongly than before. So you start trying to figure out, how do you learn about the key dimensions from the problem space, and then start trying to think about ideally longer term horizon. So even though most teams might be focused on, let's say, quarterly deliverables or half yearly, let's say, outcomes, if you just start taking a view of, these are the key dimensions, I know this is a persistent problem space, let me go after it, and let me sequence problems on a slightly longer time frame. When you start doing that, you'll start noticing that a lot of results that you're hoping for might start to come much more into effect than prior to sort of trying this out. Again, a lot of what I'm talking about, some of y'all have probably tried it out, tested it out, or intuitively are doing some of these things. It's something I wanted to point out because it becomes an interesting way to think about your problem space. And like very explicitly call out that this is one of the ways in which you can drive experimentation. The second one, this is again like a very interesting thing that people think about. And there's an interesting quote around, wait, I think I skipped a slide. Yeah. There's an interesting quote by Astro Teller, the CEO of X, who talks about, like, let's say you're trying to teach a monkey, how do you recite Shakespeare? Should you allocate your time between training the monkey versus building the pedestal? Now, most people, of course, will say, oh yeah, of course, the harder challenge here is training the monkey to, recite Shakespeare, right? But on most companies and on most business-focused teams, you are always trying to, and you always nudge to deliver outcomes in a more continuous fashion. So it's very hard to, try and go after reciting Shakespeare, but it becomes so much easier to feel that you've made progress by simply building the pedestal in those situations and feeling like, hey, I've achieved something, there's continuous progress being made, and there's continuous progress being shared with leaders across your company. So have you noticed this pattern on your team is something I'd love for you all to consider. On some teams, it's likely the case that this happens often. I'm not saying we've necessarily figured out a way to overcome all of those challenges, but this is an interesting pattern that you have to constantly remind yourself of as you're working on machine learning and data science problems. So how do you then think about this kind of a problem space, right? You have to, for example, at Thumbtack, on my team, we realized very early on that if we wanted to build some complex deep learning based models, for example, some of the state-of-the-art techniques around deep cross networks, etc., that we were trying at that point of time, we realized that we have to invest in some of our machine learning infrastructure and make those commitments on a quarterly basis. Otherwise, you sort of run into trying to do local optimization. You have your current set of features, you have a current set of models. The sort of a very clear thing that comes to mind is let's just keep iterating on the things that we know, the things that we hope will easily deliver value. It's very hard to try and say, oh, let's put in our efforts into building a much better machine learning infrastructure in order to deliver sort of that value. The third point I wanted to talk about is building alignment. Most people will probably agree, yes, it makes sense. We should always build alignment with leadership around what we're trying to achieve, right? Seems like a very clear no-brainer. What I'd like to point out is, let's say if you asked anyone on your team or even your leaders a few key questions. One, why are we sequencing experiments in a particular order? You have a roadmap in mind. You tell your leadership this is your roadmap. Are they able to explain why you have that kind of sequencing? Second, let's say, do you have a subgroup dedicated to a specific problem? And then the third is, how do you plan to embrace failure? People think about alignment in terms of leaders and folks in your teams rowing in the same direction. Yes, that makes sense. But these three key questions sort of inform, is alignment actually closer to what you're thinking about versus what leadership thinks about? So what do I mean, right? For example, how did we do that at Thumbtack within my team? I talked about maximizing learnings. I talked about sequencing experiments. So if I asked, let's say, why are we sequencing experiments in a particular order, the way we tried to push this narrative is we said, hey, we're building this kind of machine learning infrastructure. As we build a specific infrastructure capability, we'll then sequence 3 or 4 experiments that will directly use this, and then paint that journey of infrastructure, set of experiments, infrastructure investment, set of experiments. That's one way of trying to build that alignment with leadership. A second thing is a lot of teams, there's a lot of problems you might be working on, but what we found useful on my team is creating sort of a subgroup working group strategy. So having, let's say, if you have a big team, you can have 3 or 4 people consistently go after that same particular problem space so that you are able to build sort of deep expertise within that 3 or 4 group of people, and that allows you to sort of move faster in terms of how you experiment, as well as we found out that over time that leads to better experimentation outcomes. The third is a very interesting question. If you ask this to leadership, how is this particular team embracing failure? Most likely, it's not a question that they'll be able to answer, because they're mostly thinking about, hey, this is the business outcome we want. This is what we want to drive. Versus, for example, on my team, we were trying to sort of put it as, this is, let's say, a problem space like ranking. What we'll be doing is we'll be running, let's say, with an experiment velocity of 6 experiments, let's say, per quarter. And therefore, we expect one of them to succeed, leading to, let's say, a certain business outcome around conversion. I'll be talking a little more about this one in detail. Now, as I was talking about uncertainty of experimentation at the start of this talk, this is one of the most interesting and challenging aspects of driving, let's say, experimentation within any company. It is very clear that experiments will keep failing. 80%, 70%, 90%, 95% experiments might fail when you're running A/B tests. So then how do you, shift your mindset to embrace this? You want to make sure that both your team as well as your leadership is clearly aligned on the fact that, okay, this is how experimentation works. This is how it works in, let's say, a particular problem space. This is our, let's say, past history of success in this space. But when you truly embrace it, it means let's increase our experiment velocity to a point where the success that you expect can be a little more consistent. So what do I mean by that? Let's say if you know that 1 out of 5 experiments succeeds, that also means that for every win that you hope and hope to drive, you have to run 5 experiments on average to get that out there, right? So sort of embracing this means you have to focus on launching more and more and more experiments as fast as possible. A couple of things that we did, for example, is experiment setup. Very simple thing. Most experiments require some kind of setup within engineering. We said, okay, if we know we're going to run a lot of experiments, let's make it as easy as possible to do the experiment setup so that an engineer within half a day or less can just simply start an experiment as soon as they're done with offline experimentation. So that the time from offline experimentation and the numbers being shared to when you launch is that quick. The second thing is, again, for us, post-experiment analysis used to take a lot of time because we had ML engineers running and building experiments. We had data scientists then analyzing these experiments and the outcomes, the segmentation across customer bases, etc. So we said, what do we do to improve our velocity? Let's take a lot of what our data scientists do, build much more detailed and granular sort of dashboards around this problem space so that even for the data scientists, it becomes so much easier knowing that there's a consistent way to analyze these experiments, while also for the simpler experiments, you can have machine learning engineers or any engineer on the team basically look through the dashboard and have a clear sense of how you're going to be proceeding on this. This is sort of the way in which we were able to get to a point where the process of experimenting becomes a lot faster. And so that's a way you can try and embrace the fact that a lot of experiments just fail. Now, that's all I had for today's session. Just a few key takeaways, and I wanted to basically talk about some of the learnings from my time at Thumbtack, leading a lot of experimentation-focused sort of teams within the company. And I know, of course, that a lot of what I talked about might seem obvious, but it's good to try and do a retrospective on what is it that led to success on your respective teams, and try and think about these 4 key points when you're thinking about how you're shaping experimentation culture on your different teams. Of course, I also expect that only some of these learnings might be applicable to your respective teams, but hopefully these are good starting points for you all to think about the problems within your respective teams and companies. That's all I had. Any questions?
How challenging was it to get buy-in from leadership?
I think that's always a challenge, but that's what I was pointing at. What you at least want to do is make sure that they are on the same page, that they realize how difficult it is to get, let's say, success in a particular problem space. Making sure that they understand that, okay, let's say, for example, the first time you're running an experiment, you may have no idea what your experiment success rate might be. In stable problems where you're consistently running, let's say, a set of experiments, there you can start saying things like, hey, there's going to take about 3 or 4 or 5 experiments to get each win. So making sure that they understand sort of your perspective on how many experiments it takes to build that win, I think that tends to be something, at least I have focused on quite a lot. I've been encouraging everyone within Thumbtack to try and think about it from that perspective. I am not going to say it's easy and it just happens. It is a challenge, but there's at least a way of trying to build that alignment from a very experimentation standpoint. Thank you.
Thank you.